Okay, this is a homework help video for the beginning of the fall final review. So this is homework help video number 1. So one of the things that you may want to do if you haven't already is try to find your lesson on Unit 1 Objective 2, which gives you your parent functions and then your shifted functions, and it helps you kind of review how to graph. So you should try to find this one here, okay? All right, so for question number 1, so you want to write the equation. So this is a linear equation. So the standard form for a linear equation is y minus k, and then equals m times x minus h. Okay. And so you want to find your start point and a second point. So I'm just going to put a dot here, so that would be at 0, -1, and a second dot here at 2, 0. And for lines, it doesn't matter what your start point is versus your second point because it's linear. So I'm just going to choose this one right here to be my HK, and this one to be my XY. And it doesn't matter, again, which one I had chosen, so if this is flipped, I'll still get the same answer. So then from here, I'm going to replace everything up here to find m. So I know that y is 0, so I'm going to replace y with 0. And I know k is -1, so I'm going to replace k with -1. And so I have a minus that needs to stay, and k is -1, so I'll have a double negative here. And I'm trying to find m. And then my x value is 2, and my h is 0. And then from here, I just want to solve for m. So the double negative would be a positive, and 0 plus 1 is 1. And then 2 minus 0 is 2, and I don't want to write it as m2, but put it in the correct order, so that would be 2m. And then to solve for m, I would divide by 2. So then I know m is equal to 1/2. So then once I have that, I'm going to go ahead and rewrite my equation. But when I rewrite my equation, I'm going to replace m, k, and h. And so my final answer should always have the x and the y. So I'll have y minus k, so minus a -1, so that'll be a +1. And then equals to m, which was 1/2, and then x minus h, and h was 0. And there's my linear equation. Okay, let's do the same thing for number 2. So for question number 2, my vertex, which is right here, that's my HK, right? So my vertex is always my HK on my parabolas. So that's at -2, 0. And then I want to choose a second point, so I'm going to choose this one here, which is at 0, -2. And then that basic equation is y minus k equals a, and then x minus h squared. And again, if I don't know these, I can always look back on that summary. Okay. And so my vertex here is my HK, and then this is some other random point on my graph, and so that would be my x and my y. So I want to replace y with -2, and I want to replace k with 0, and I'm trying to solve for a. And then replace x with 0, replace h with -2, and then I still have the squared. And then I want to simplify that. So -2 minus 0 is -2. And then this will end up being a +2, right? And then 2 squared is 4, so then this is 4a. Divide both sides by 4. And then -2 divided by 4 reduces to -1/2. And then my final answer, I want to replace K, A, and H. So I'll have y minus k, and k was 0. A is -1/2. And then x minus h. And h was -2. So x minus the -2. And then don't forget your squared. And then I have a double negative here, so that would be a positive. And I don't have to have the 0 here, so I could just rewrite it if I wanted to as y equals instead of y minus 0. Okay, so for question number 2, this one's exponential. So this equation is y minus k, and then is equal to a to the power of x minus h. Okay, so again, if you don't know these, you can look them back at your study guide. So for my exponential, I know that one below here is my asymptote, and so that is my start point. And that is at 1,2. And then my stretch is to here, so I go over 1, and then up, let me see, 1, 2, 3. It's like I'm going over 1 and up 3, 1, 2, 3, yeah. So then my stretch is 3. Okay. So I have my stretch is 3, and k is 2, h is 1. So for my equation, I would have y minus k, which is 2, and then my stretch is 3, and then x minus h, which is 1. Okay. All right, so just a reminder, whenever we find a, it's always over 1, right? We can't go over half or over 2 or over 3. It's always over 1 and then up however many. So it took me 3 units to get to my function, so then a would be 3. So for my absolute value, my vertex here is my hk, so that is at 2, 3. And for my stretch, it looks like I can find my stretch pretty easily. So I'm going to the right 1 and down 2. So then my stretch or slope would be -2, or -2 over 1, or -2. And then my equation is y minus k equals a or m, it doesn't matter the variable, and then x minus h in absolute value. So that would be y minus k equals a, which is the same as m, and then the absolute value of x minus h, and h is 2. All right, so for question number 5, I want to graph this. So I'm going to put this in standard form, so I'm going to subtract the 2 to the other side. So for my start, I want to do the opposite here. So instead of -1, I'm going to use +1. And then instead of -2, +2. So I'm going to go over 1, up 2. And then this is linear because there's no absolute value, no squared, and it's not up in the exponent. So because it's linear, I can treat my stretch differently, and I can actually go up 2 and over 3 because it is linear, so the rate of growth is constant. So I'm just going up 2 over 3. If this was any other type of graph, I could not do that, right? And then for domain and range, I want to label my 4 corners. So I want to do all the arrows first. So I'm going to look at this arrow here. And remember that arrow takes on 2 directions. It's going up and to the right so both of those corners will be positive because I'm going, or positive infinity, because that arrow is always going to be implying an infinity forever, and so it's going up and right. This arrow here is going down and left, so both of these corners will be infinity as well, but negative. So for my domain, it's left comma right. And then my range is bottom comma top. And then infinities always get parentheses. Okay, so for question number 6, I want to subtract 2 to the other side to put it in standard form. And then for my start, it's +1 and +2. And then my stretch is -1/2. So I'm going to go over 1 and up 2. And then down 1/2 over 1, down 1/2 over 1. So I can't go down 1 over 2 because it's not linear, right? So because it's a square, that means it's going to be a parabola. And so that means I can only always go over 1, so down 1/2 over 1. And I could not keep repeating that because it's not a constant rate of growth. And then for my domain and range, I want to label my 4 corners, so I always start with the arrows. So I'm going to start with this arrow here first. So it's going down and to the right, so the right would be positive infinity, and the arrow is also going down, so negative infinity. And then I'm going to look at this arrow here. Also going down, which is labeled, and to the left, so negative infinity here. So these 2 arrows filled in these 3 corners, so now I need to find how high it goes, which will not be infinity. So I'm just going to count to see how high my graph goes. So from the x-axis, 1, 2, so the highest it goes is +2. So then my domain is left comma right. And then my range is bottom comma top. So because that's a closed dot and inclusive, then it's going to be a bracket. Okay, let's take a look at question number 7. So I want to put this in standard form, so I need to subtract the 2 over. So my start is going to be opposite here, so -4, and opposite there, so +2. So -4, +2. And then my stretch is -1, so there's always that implied 1. So from here, I'm going to go down 1 over 1, and then reflect and do the other side. So this is an absolute value, right? So just looking to make the 3 dots here. And then connect. And then for my domain and range, I'm going to look at the arrows. So this arrow is going down, so negative infinity, and to the right, so positive infinity. Then I want to look at the other arrow here. So this arrow is going down, already labeled, and left, so negative infinity. And so both of these arrows cover these 3 corners, and I'm left to find the top corner. So I want to know how high my graph goes, and this is the highest point, and it's 1, 2 above the x, so that would be +2. So then for my domain, it's left comma right. And then my range is bottom comma top. And it's a bracket on the 2 because it goes up to 2, including the dot, so closed dot. Okay, so let's take a look at question number 8. So I don't have any number being added out here, so then I don't have a value added to y. So then that means for my start, it's going to be at +1 and then 0 because I'm not adding anything to 0. And then my base or my stretch is 2. So here I go to my start point, which is 1, 0. And so now for the exponentials, these are very different, right, from anything else. So that start point is actually my asymptote. So at 1, 0, I'm going to draw in a dotted line. So that's my asymptote. And then I'm going to do my stretch, which is up 2 over 1. And then I need one more point, and that's always 1 above, because if I put 1 into here, that gives me 2 to the 0, which is 1. And so now my graph, I grow to the left towards the asymptote, not crossing, and then up and to the right. So now for my domain and range, start with my arrows. I'm going to start with this one. So it's going up forever and to the right forever, so both positive. So normally arrows always take on 2 directions unless there's an asymptote keeping it from going one direction. So this is going forever to the left, but it can't go forever down because of that asymptote. So this keeps me from going down forever, and so then this ends up being my lowest point, right, is my asymptote, and that's at 0. And so my domain is left comma right. And then my range is bottom comma top. So this time the 0 is actually going to be a parentheses because the asymptote is not part of my graph, it's a boundary of my graph. Okay, so for question number 9, these are restricted graphing. So these are a little bit different. So I'm going to need a little extra room here. So I always want to start by plugging these two numbers into here to figure out my ordered pairs of where my graph is going to start and stop. So I want to take the -1 and substitute it in for the x. So that would be -3 minus 2, which is -5. So then that means at -1, I have the ordered pair -1 comma -5. Right? So when x was -1, I got y equals -5, and that's going to be an open dot because I can't equal it, right? So if there was a bar underneath it, I would use a closed dot. And then I want to do the same thing again, and I'm going to do it for 2. So I want to do for x equaling 2. I want to substitute that into that equation. So 3 times 2 is 6, and 6 minus 2 is 4. So when x was 2, I got the value of 4. And then because there is a line underneath, I'm going to use a closed dot. So this is where my graph is going to start and stop, right? So it's going to start here because x is greater than that number. And then it's going to stop here because x has to be less than that number. Okay. So at -1, -5, there's going to be an open dot. And then at 2, 4, there's a closed dot. Okay. So I know whatever this graph ends up doing, it's not going to be drawn completely. It's only going to be drawn between these 2 dots here. And so if I look at this graph, I'm going to add the 2 over to my y. And then my start is 0, comma -2, because I'm not adding anything to 0. And then opposite here. I mean, adding anything to x, and then opposite there. So over 0, down 2. And then my stretch is 3. And then it's linear, so I'm going to go up 3 over 1. And then this is just going to be a straight line that starts at the open dot and ends at the closed. Okay, so for question number 10, I want to start it the same way. So I want to start by substituting x with -3. So I replaced x with negative 3. Negative 3 plus 1 is negative 2. And then the absolute value turns things positive. So 3 times 2 is 6. And 6 minus 4 is 2. So when x is negative 3, I get 2. And there's a bar underneath it, so that means it's equal. So then I use a closed dot. And then do the same thing again for the 0. So I'm going to take the x and replace it with 0. So 0 plus 1 is 1. 3 times 1 is 3. And 3 minus 4 is negative 1. So when x is 0, I get negative 1. And it's an underlined inequality, so then that means it's inclusive, so it would be a closed dot. So I'm going to go to negative 3, positive 2, put a closed dot, and 0, negative 1, and there's a closed dot. And then I want to graph it, and so I'm going to go ahead and put this in standard form. So add the 4 over. So then my start is negative 1, negative 4. And my stretch is 3. And then, so from here I'm going to go up 3 over 1, and then up 3 to the left 1. And so for my absolute value, normally I would just graph it forever, but because I have a start and a start and stop dot, I want to start here and there. And then that is page 1 of the fall final review.